So last video we discussed how we can find a limit graphically and how we can find limits at a certain value by using a table of values. There is also the situation though where a limit can fail to exist. There are three conditions when this occurs. So the first example is a jump. So like if you have a piecewise function. This limit doesn't exist because it approaches a different number from the left side than from the right side. If we look at the first example, the limit as x approaches 0 of f of x doesn't exist because if we look from the left-hand side, the limit as x is approaching 0 is -2. But from the right-hand side, the limit as x approaches 0 is +2. Because -2 and +2 are different values, we say the limit here does not exist. The second condition is if the function contains a vertical asymptote, and therefore our function is increasing or decreasing without bound as x approaches c, our value. So here, our limit as x approaches -2, you can see here at -2 we have a vertical asymptote. So the limit as x approaches -2 does not exist. It doesn't approach a value. Our last condition is if the function oscillates between two values as x approaches c. So here the limit as x approaches 0 of f of x. So as f of x is approaching 0, our function's oscillating. It's going to keep going back and forth forever. So it's not approaching a specific value, so the limit does not exist. Okay, so previously from the previous video, we looked at the value of a function as x approaches c from each side of the function, and that's called a two-sided limit. But if we look at example 1, the function approaches a different value from the left side of c than it does from the right side of c. So this behavior can be described in terms of one-sided limits. So one-sided limit is exactly what it sounds like. We're just looking at limits from one side. So from the left side, if the value of f of x approaches a unique number, limit 1, as x approaches c from the left, then it's written like this, LIM for limit x as x is approaching c from the left side. Now the way we distinguish left from right in terms of limits is for left above c and to the right, there will be this minus sign, this negative, indicating that we're approaching the limit from the left. And from the right, if you look right here above c, there's a plus sign. So from the positive value, we're approaching the limit from the right. Let's see an example of this. So evaluate each limit using the graph here. So our first one's approaching from the left. The limit as x approaches 2 from the left of this function. So from the left as x approaches 2, well, x is 2 here. From the left, our graph is approaching from this value here. F of x is equal to -1, so it's approaching -1. Now let's look at the limit from the right. So as x approaches from the right-hand side, as x approaches 2, it's approaching this value of +1. So here we can see the limit from the left and the limit from the right give us two different values. They're approaching two different numbers. Okay, let's do this next example. Evaluate the limits for each given function. There's just this one. So f of x is equal to this piecewise function. So here we're looking for the limit of f of x as x approaches -3 from the left, and then also as x approaches -3 from the right. So if we look here, we have a piecewise function, and right here, when f of x is equal to -3, we would use this function, -x minus 5. But let's graph this so we can clearly see what's happening from the left and the right hand side. So I'm going to open up another tab. I could have used the other one and just X'd out, but I want to keep that for right now. So I'm just going to open up another Desmos tab, and I'm going to type in our function f of x is equal to negative x minus 5. It is piecewise, so to account for this, I'm going to use the curly braces. X is less than, less than or equal to negative 3. Of course, if you have your graphing calculator at home, you can just use that. But if you don't have one, then you can do what I'm doing and use Desmos. Okay. Or you can graph by hand too. Okay, so here we've typed in our function f of x is equal to negative x minus 5, and I forgot the equal sign here, 2x minus 1 when x is greater than negative 3. So we can see, let me move it a little bit. Here we can see our piecewise function. So here they wanted us to evaluate the limits. The first one, as x approaches negative 3 from the left-hand side. So let's see. As x approaches negative 3, so here's negative 1, negative 2, negative 3, from the left-hand side. So as we approach from the left, we're getting closer and closer to this value here, which seems to be negative 2. Okay, so our limit here as x approaches negative 3 from the left-hand side is negative 2. Now let's look and find the limit as x approaches negative 3 from the right-hand side. So from the right-hand side, as x approaches negative 3, it's getting closer and closer to this value here, which it's going to say undefined because it's not equal to, it's strictly greater than. But if we slide this point, we can see it's getting close to negative 6.7, 7.2, 7.6, 6.8, negative 6.9. It's getting closer to the value of negative 7. It's approaching negative 7. So the limit of f of x from the right-hand side is negative 7. So previously I mentioned that in some instances limits do not exist, right, D and E. So a two-sided limit exists if and only if both the left and right limits exist and are equal. What this means is if I was to go back and look at this example here, evaluate each limit using the graph, but I added an additional limit and I said just the limit, should I type this out? The limit as x approaches 2. And I don't specify left or right side. I just want to know the limit as x approaches 2 of this function here, f of x, absolute value of x minus 2. And I'm just going to say that's f of x, so I don't need to rewrite it here. What would that equal to? Because the left limit is equal to negative 1 and the right limit is equal to positive 1, because those are two different values, I would say the limit as x approaches 2 does not exist. Separately, I can find the limits, but together it doesn't exist. Likewise for this example here, as x is approaching negative 3. From the left we can find the limit, from the right we can find the limit. But together it doesn't exist because they're not the same. If the values equaled, if they approached the same value, if the limits approached the same value, I should say, then it would be that value c.